Hello, Alex Caithness here. I'm the lead developer on RabbitHole, and in this video I'd like to talk to you about some of the new data formats we've added support for in version 2.1, in particular those related to Chrome, Chromium and Electron. First, a little background. We are at this point, I think, all familiar with the Chrome browser. It is, at the time of making this video and for the foreseeable future, I think, the browser with the largest market share. Its influence, however, reaches further than that, with a great many other browsers such as Edge, Opera, Brave, and the like being based on the open source Chromium project. This means that a great many browser artifacts which you will come across will be related to and reminiscent of those that you find in Chrome. Looking beyond the browser marketplace, Chrome's technology is leveraged to build other desktop applications such as Teams, Discord, Skype, and many more, as well as being a core underlying component of a wide range of applications in the Android ecosystem. What this means is that there is a convergence in the way that a wide range of desktop and web applications are having their data stored, which is why in this new version of RabbitHole, we've added support for 3 of these new storage mechanisms: local storage, session storage, and indexed DB. All 3 of these formats are backed by a level DB store, and if you're interested in understanding how the data is structured in depth, I'd highly recommend taking a look at the series of blogs we've already published on the subject. For now though, let's dive into the functionality of these new views. Let's start with local storage and session storage. Both of these technologies work in similar ways. They are text-based key value stores, and in the context of a browser they can contain stores from multiple domains. The main difference in functionality between these 2 related technologies is that local storage is designed to store records indefinitely, or until a user chooses to delete the records, whereas session storage is designed to be isolated to a single browsing session in a single window or tab, and be deleted afterwards. Which it is, but because it's based on a level DB data store, we can very often recover deleted records. Generally speaking, you'll find local storage conveniently located in a folder called local storage and session storage in a folder called session storage, so even in the differing environments they're usually easy to spot. Because LevelDB is being used here, this whole folder is actually the data store, and by bringing one of these files in, RabbitHole will automatically scan the rest of the folder and rebuild the whole database. Both of these formats are presented in RabbitHole's familiar tree view, and both support text and regular expression search, and the same tree parser reporting functionality that is present in most hierarchical data formats already present in RabbitHole. In the lower left corner of the interface, we have a grid which gives us details on the provenance of each record. This includes which of the files making up the LevelDB store contains it, its offset within the file, and the LevelDB sequence number, so that you can investigate the raw data if you need to. It also contains the metadata for the record, which in the case of local storage will include a batch timestamp, which gives a fairly good indication of the time that the record was inserted into the local storage, with a latency of somewhere in the region of 5 to 60 seconds. More detail on this timestamp can be found in the blog posts. We can expect to find a wide range of artifacts here depending on what any one particular site is using it for, but for example here in this test data we can see some Google search terms in the sp_wiz_pq key. The key here has been updated at least once, which is why we can see 2 values, and we can infer the order in which the searches were made based on the sequence number shown with each value. It appears that these records were inserted into the database at the same time, or at least within the space of a second, but in this subsequent key we can find some timestamps which relate to these searches, and we can see that not only were they made a number of seconds apart, we can also see that latency at play. Moving on to IndexedDB. These files tend to be found again conveniently in a folder called IndexedDB, but unlike the local and session storage databases, IndexedDB data stores are separated up by host. Again, the database is backed by LevelDB, so the whole folder contains the data for the database, and RabbitHole will pick up the whole folder when we bring in a single file. This data is actually from the desktop Microsoft Teams application, which is built on the Electron framework, which itself makes use of technology from Chromium. So this is a great example of Chrome-style artifacts being found in applications which aren't even browsers. Each IndexedDB can contain multiple databases, as is the case here, and each database can contain multiple object stores, which you can think of as being similar to tables. If we wanted to recover some messages from here, there are a few different places we can find messaging data. We'll use the conversations object store in the conversation manager database for this example, but the reply chain manager can also be a good source of data, and ultimately you'd probably want to amalgamate and deduplicate across various areas of the database to maximize what you can recover. This object store contains multiple entries, but on closer inspection we can see that actually we have the same key repeated for every record here, which shows a key which is being updated over and over again. That's because this object store relates to the state of a conversational meeting rather than individual messages. But if we dig down into the data held by this key, we can find information on the last message for the meeting, including message content, user details, timestamps, and so on. So we can make use of RabbitHole's tree parser functionality to quickly build a query which can pull this data back into a report. If you need more detail on the tree parser, we have a video on our channel which goes into the feature in depth. Version 2.1 of RabbitHole brings with it a whole host of other newly supported data types, as well as new features and enhancements to the existing support, and this update is free for all current customers. If you're interested in purchasing RabbitHole or getting access to a free trial, get in touch by emailing sales@cclsolutionsgroup.com. Thanks for watching.